Hi, today I'm going to talk about our IRE major project, that is community detection for research papers. The task given to us is to detect communities within a network of research articles. Now, research papers are represented in the form of a network or a graph. In this network, the nodes represent either the research papers or the authors, and the edges represent a relationship between the two nodes. Now, there are several ways to define such a relationship. An example would be a paper citation relationship, where if a paper A cites another paper B, the two are said to have an edge in the network. Now, what do I mean by network communities? A network is said to have a community if there are a group of nodes in the network that are densely connected internally with each other. And such a group of nodes have several other properties such as compactness, density of edges, separation, and mutuality of ties. In this network here, it is easy to see that these group of nodes form a community as they are densely connected with each other as compared to other nodes in the network. Now, we basically constructed a network graph from the available data using 4 metrics, 2 weak metrics and 2 strong metrics. Here, metrics refers to the relationship between any two nodes. The weaker metrics we use for paper titles, year of publication, whereas the stronger metrics used for paper citations and author citations. The data set we used for our project was the AAN data set that has around 20,000 papers. Now, community detection can be seen as a graph clustering problem as well as a graph partitioning problem. When we see it as a graph clustering problem, we first have to define a similarity measure between any two nodes in the network. The two similarity measures we use were cosine similarity and Jaccard similarity. Cosine similarity is defined as follows, where A and B are a vector representation of the node, whereas Jaccard similarity is defined as such, where A and B are the neighbor sets of the two nodes. A neighbor set for any node is basically all the nodes linked to it in the network. Now, once we have defined the similarity measure, we group similar nodes together using a clustering algorithm such as k-means. The k-means proceeds by choosing k random centroids or nodes in the network and then clusters similar nodes together using those centroid nodes as a reference. Now, community detection as a graph partitioning problem finds communities based on the structural similarity of the nodes in the graph. We look at two algorithms, that is Newman-Gilvin algorithm based on edge betweenness and Louvain algorithm based on maximizing modularity. Newman-Gilvin algorithm is based on the idea that the shortest path between any two nodes belonging to different communities will always include the edges linking the communities. These edges that link communities can be thought of as bridges. So, as we proceed in the algorithm, the edges with the highest betweenness value are removed from the graph, and as a result, the graph is split into multiple components. Each component can be thought of as a network community. The algorithm proceeds as long as edges remain in the graph. This is one of the plots we got by running Newman-Gilvin on the data in an unweighted author citation network. The different colors represent different communities. The Louvain algorithm partitions the graph by optimizing the graph modularity measure. The graph modularity measure is a measure of the quality of communities found. So, the basic idea is to continuously improve the quality of communities found by assigning every node a certain community. Now, every node initially is assigned its own community. Then we iterate over every node and add it to the community that results in the highest modularity. The change in modularity is found using the given formula. Higher the modularity, the better the communities are. As the nodes are added into a given community, all the nodes within a community are now grouped and form a single node in the new network. And the algorithm is repeated so as to give us the final output, that is where every node is mapped to a certain community. This is one of the plots by running Louvain on a weighted paper citation network. Again, the different colors represent the different communities in the network. We use Jeffy tool to plot such graphs. Thank you.